Okay, so this is Room Connor, and I am going to be learning the Rust programming language. Um, this video series is me learning the language myself, so it's needlessly long. It's not a tutorial for you guys. It's just for those of you who are curious as to how other people learn things. Yes, and I like documenting what I'm doing as well. So if you're looking for a tutorial, I might have one up. If I don't, there are many Rust tutorials on the internet. All right, that said, let's try and get started. Forward. Empowerment. System level. Low risk operation. Okay. I know like Rust is basically a safer alternative to C. With C, I was always curious as to why people did not implement any measures to prevent undefined behavior in the first place. And Rust is the answer to that. And it's great for concurrency as well. Let's go. Getting started. Installing Rust. Yeah. All right. So command line, installing Rust on Linux. I have Windows. So here you go to this link, install Rust, download Rust up in it, 64-bit probably, depending on your system, but probably your system is 64-bit if it's a modern computer. And you go ahead and click on that and run it. And then proceed. Enter. It's already installed on my system, so I'm just pressing the enter key to continue. It's a good idea. Well, it installs Rust under a user's directory, cargo, and cargo bin folders and stuff. You might want to change those if you go to environmental variables here, environment variables, and change your stuff. Cargo home, go to new and you create a variable name called cargo home and then change the directory to whatever you want here. I changed it to code rust cargo. And all my API keys are here. How nice. And I'm gonna make new ones, I guess. And there's also Rust up home, this thing, where Rust up things are. I don't know what Rust up is. So there is another folder basically called Rust up. And you can change it using a keyword here, key value pair. Okay, there's also path. Yeah, so you need to add it to path, your bin directory under .cargo bin, this thing, wherever it is, needs to be in your path. I did it both for Rune, see my username, and the system variable path here. I did it for both. Right there. Okay. Once you install it, I guess I'm going to continue now, assuming you have installed it. Troubleshooting, blah, blah, blah. Echo path. I'm going to use PowerShell here. Echo path. What is that? Rust C version. Rust C version. Okay. What is that? Yeah. Echo path. What are you doing? What is this? Doesn't do anything. Oh, okay. Echo and path. That's PowerShell. Okay, those are all the paths. It's all correct and update. Rust update. Yeah, it's already up to date. That's it. All right, let's continue on. Hello world. Now that I've installed Rust, it's time to write my first Rust program, huh? Tradition, blah, blah, blah. We need a Rust analyzer. Okay, get our VS Code here. Working. This was Hugo. Let's close that folder. And oh, no. Let's see, Rust analyzer. Just Rust, maybe. 5 stars. Okay, nice. And there's a fork for some reason. Okay, what happens when I install it? Project directory. You'll start by making your directory to store your Rust code. Doesn't matter to Rust where your code lives, but for exercise, I suggest making a projects directory in your home directory. Keep all your projects there. What is my home directory again? Rust home. Cargo home. Is it cargo home? Or it's the user home directory. I see. Nah. Let me make a folder somewhere. I am gonna make one under code Rust and then project. Okay, what now? Hello world. No, I don't want to do that. Hello world. Projects hello world. Okay. Let's create a folder. New folder. There we go. Make a new source file and call it main.rs. Are you done? Yep. So file, open folder. Let me browse to code Rust projects. There we go. Yeah. Main.rs. Use hello underscore world. Okay. Main.rs. Hello world. Let's get a new file there. Main.rs. And we are typing in Rust code. fn main println. fn main. And then print ln that. And hello world. Hello world. Rust analyzer, what you doing? Failed to discover Cargo.toml of the workspace to the linked project setting. What is that? What? I hate this. Okay, let's see. Save the file and go back to your terminal window on Linux server, blah, blah, blah. Rust C main rs. No. Let's see. Get our PowerShell into taskbar. And let's go to D. Code cd rust, cd projects, cd hello world. No, here. Oh, cd underscore rust c main.rs. Okay, we compiled it. Now main house properties. Really? What the heck is this? What just happened? Main.exit. Okay, there we go. Main is actually a command on Windows, probably. That's funny. So main, you gotta do main dot. Say no, does not found, exists in the current location. PowerShell does not load commands from the current location by default. If trust this command inside type. Interesting. Okay. So you gotta type it like that. / main dot. Interesting stuff. Regardless of your operating system, the string hello world should print to the terminal. If you don't see this output, refer back to troubleshooting. If hello world did print, congrats. Anatomy, let's review this hello world. Function main, that's the function. The main function is special. It's always the first code that runs in every executable. So this is the entry point of the program. Parentheses are denoting that it's a function, and fn is the function definition keyword for Rust. Okay, so that is the body with curly spaces, nothing new here. Just like C family languages. Automated formatter. I haven't been able to get the Rust analyzer to work. Reload. Workspace. Cargo.toml of the workspace to the linked project setting. Come on, man. Rust analyzer. Error last failed to find any projects. But it says project. Yeah, I guess I need a Cargo.toml. Some haven't worked with it yet. We end the line with a semicolon, which indicates that this expression is over. Oh, semicolon. I didn't add it. Still worked because it's just a single line. I didn't. I think Rust did away with semicolons though. That's what I thought anyway. Fourth expression is over. Okay. Compiling. Yeah, that's the compiler, Rust compiler. So Rust C is the Rust compiler. On Linux, I don't care. If your main RS is your hello world program, prints the terminal out of time compiled. So you compile first and then run it. You'll want to manage all the options and make it easy to share your code. Next, we'll introduce you to the Cargo tool. Yeah, let's do that. Cargo is Rust's build system package manager. Most Rust people use this tool, Rustaceans, that's Rustaceans. Use this tool to manage their Rust projects because Cargo handles a lot of tasks for you. Simplest Rust programs don't have any dependencies. If we had built the Cargo, it would only use a part of Cargo that handles building. Because the vast majority of Rust projects use Cargo, the rest of this book assumes that you're using Cargo too. Cargo comes installed with Rust. If you install Rust, Cargo version. Let's do cargo version. Cargo version. Okay, we got a version. Creating a project. Let's create a new project using Cargo and look at how it differs from our original Hello World project. Cargo new Hello Cargo. Okay. Do I have to work on in the terminal, man? Cargo new Hello Cargo. Why? Maybe Hello Cargo. Got it. Git ignore and Cargo.toml. Go into Hello Cargo, has a 2 files, Cargo.toml, and a source directory with a main RS file inside. Really? Oh yeah. It has also initialized a new Git repository. You can override this behavior using Cargo new ECS Git. And Cargo.toml in your text editor. All right, let's see. Cargo.toml. Here we go. And then what? This file is in the toml format, which is Cargo's configuration format. The first line, package, indicates following statements are configuring a package. As we add more information to this file, we'll add other sections. Next 3 lines set the configuration information. The addition of Rust use. We'll talk about the addition key in Appendix E. Last line, dependencies, at the start of a section for you to list any of your project's dependencies. In Rust, packages of code are referred to as crates. We won't need any other crates for this project, but we will in the first project in chapter 2, so we'll use this dependencies section then. Now open source main rs and take a look. Okay, source main rs, the same thing. Cargo generated a Hello World program for you, just like the one we wrote. So far, the differences between our project and the project Cargo generated are that the Cargo placed the code in the source directory, and we have a Cargo.toml file. Cargo expects your source files to live inside the source directory. The top level project directory is just for README files, license, configuration, anything else not related to the code. Using Cargo helps you organize your projects. There's a place for everything and everything in its place. Okay. If you start a project that doesn't use Cargo, as we did, everything is in its place. So in the you can convert to a project that does use Cargo. I wanted to a German accent here, but I couldn't. I failed. Move the project code in the source directory and create an appropriate Cargo.toml file. Yeah. Okay. Building and running a Cargo project. Now let's look at what's different when we build and run the Hello World program with Cargo. From Hello Cargo directory, build your project by entering the following command, cargo build. Okay. Hello Cargo, cargo build. Nice. This command creates an executable file and target debug Hello Cargo. Rather than your current directory. Because the default build is a debug build, Cargo puts the binary in a directory named debug. You can run the executable with this command. Target. I'm using backslashes because that's the Windows thing. Hello article. Right. I got hello world. Oh, there we go. They added that. All goes well. Hello world should print to the terminal. It did. Running cargo build for the first time also causes cargo to create a new file at the top level. A cargo lock. Does it now? Yeah, right there. This file keeps track of the exact versions of dependencies in your project. This project doesn't have any dependencies, so the file is a bit sparse. You won't ever need to change this file manually. Cargo manages its contents for you. We just built a project with cargo build and ran it with that, but we can also use cargo run to compile the code and then run the result. Okay, that's better. Cargo run. Hello world. Nice. Using cargo run is more convenient. Yeah. Cargo run. Notice that this time we didn't see output indicating that cargo was compiling. Cargo figured out that the files hadn't changed, so it didn't rebuild. It just ran the binary. If you had modified your source code, Cargo would have rebuilt the project before running it, and you would have seen this output: compiling, finished, and then running. Cargo also provides a command called cargo check. Checks your code to make sure it compiles, but doesn't produce an executable. Why would you not want an executable? Often, cargo check is much faster than cargo build because it skips the step of producing an executable. So optimizations, maybe? If you're continually checking your work while writing code, using cargo check will speed up the process of letting you know if your project is still compiling. Such many rusty stations run cargo check periodically as they write their program to make sure it compiles. Then they run cargo build when they're ready to use the executable. Let's recap. We can create a project using cargo new. We can build a project using cargo build. We can build and run using cargo run. So cargo new, cargo build, cargo run. And then can build a project without producing a binary to check for errors using cargo check. Instead of saving the result of the build, cargo stores it in the target debug directory. Additional advantage is the commands that are the same no matter which operating system you're working on. Will no longer provide specific instructions for Linux and macOS versus Windows. Okay, building for release. When your project is finally ready, you can use cargo build release to compile it with optimizations. Oh, okay, so build doesn't do optimizations. Anyway, I wonder how this is faster than cargo build. It skips the step of producing an executable. Oh, it just doesn't produce the file. So write to disk. That's the only thing. Or maybe building checks for syntax errors first, or any errors first. So check is done in the build stage as well before actually running the instructions of the program. No, you're not running the program, you're building the program, building from source code. Maybe these are two separate steps in the build thingy. I don't know. No idea what I'm talking about. I've never built a compiler in my life. Okay. Cargo's convention. Be sure to run cargo build release and benchmark with the executable in target release. That won't be rebuilt repeatedly, and that will run as fast as possible. If you're benchmarking your code's running time, be sure to run the release build, okay? With simple projects, Cargo doesn't provide a lot of value over using Rust C. but it will provide its worth as your programs become more intricate. Once programs grow to multiple files or need a dependency, it's much easier to let Cargo coordinate the build. Even though the Hello Cargo project is simple, it now uses much of the real tooling you'll use in the rest of your Rust career. Am I gonna have a Rust career? Stands to be seen, I guess. In fact, to work on any existing projects am I going to be able to actually be a Rust programmer? In fact, you can use the following commands to check out the code using Git, change to that project's directory, and build. Git clone, okay, cd some project, and then cargo build. Oh, okay, nice. Already off to a great start on your Rust journey! Exclamation mark. In this chapter, you learned how to install the latest, update, open locally install documentation. Where? I didn't do that. Write and run a Hello World program using Rust C. Create and run a new project using the conventions of Cargo. This is a great time to build a more substantial program. All right, chapter 2. So I am gonna continue this in the next part of me learning Rust series. See you guys then.